Hi everyone, I'm Doug from DigiPen in Redmond. In this video, we'll use some mathematical trickery to make our enemies zip around the screen like flies. Imagine again that you're on your bike and that you're going 5 meters per second to the east. To simulate this in a game, using velocity, we would nudge you along to the east by a small amount again and again. If you were going faster, we would nudge you further each time. If you were going in a different direction, we would change which way we nudged you. This is one way of moving something, but there's another way. Instead of nudging you a set distance again and again in a chosen direction, we can pick a spot for you to move to, called the destination, and decide how long it should take to get there, called the duration. Then we can make you smoothly slide into place. It's like we've set up a little miniature journey in a straight line. Here's where you are now. That's the starting point of the journey. Here's the spot we picked for you to move to. That's the ending point. But the journey includes every point in between as well. Here's a question. If your trip starts here and ends here, and it takes 10 seconds, where will you be when you've been moving for 5 seconds? Well, 5 is 50% of 10, so you will have gone 50% of the way. This means you will be right at the midpoint between the start and the end. Where will you be after 9 seconds? 9 is 90% of 10, so you will be 90% of the way from the start to the end. We can pick any percentage of our chosen duration, and you'll be that same percentage of the way into the journey. If we gradually change this percentage value over time from 0 up to 100%, then we can watch you smoothly slide from the starting point to the destination. We can start with any 2 points and use a mathematical formula to find any point in between them. This is called linear interpolation, or lerping. It's a great way to move something in a game when you know exactly where it should end up. Linear interpolation can be used for moving things, but it can also be used for many other purposes, from rotating an object to changing a sprite's color. Scratch lets you use the lerp formula to move sprites with the glide block. In fact, we've already used it. The hero uses a glide block in the starting sequence function. You just tell it where the sprite should go and how long it should take to get there, and Scratch handles the rest. Let's make the enemies in Scratch Invaders move around the screen with linear interpolation. Load what you've already done in that project, or visit the link in the description below, and then click the See Inside button. Begin by selecting the enemy sprite in the Sprite pane. Just as we did before when we gave the enemies the ability to attack, we're going to add another When I Start as a Clone block. You can add as many of these as you like to a sprite. Click the gold Control category on the left. Find the When I Start as a Clone block and drag it into the code area. What we're going to do is cause each enemy to pick a random position near them and then glide to it, and then wait a few moments when it gets there before doing it all again. Since we'll be doing this over and over, we'll need a loop. Find the Forever block in the block palette, drag it into the code area, and attach it to the bottom of the When I Start as a Clone block you just added. We want the enemies to pause for a moment before each movement, so find the Wait block and attach it inside the mouth of the Forever block. We'll pick a number to put in its value field in a little while, but first, let's get movement working. We want to make the enemy pick its destination and move there, so let's put that in its own function. Click the pink My Blocks category, and then click the Make a Block button. Name the new function Move. In the block palette, find the Move block. Attach it to the bottom of the Wait block inside the mouth of the Forever block right here. Remember, when using linear interpolation, you want to have a destination picked out ahead of time. Let's create a pair of variables to keep track of the movement destination. Click the orange Variables category, and then click the Make a Variable button. Name the new variable MoveEndX, and make sure you select the For This Sprite Only option. Make another variable called MoveEndY, and select For This Sprite Only for that one too. Find the Set block and add 2 copies of it to the Move function. In the first one, select MoveEndX. In the second, select MoveEndY. The numbers we put in these value fields will determine where the enemy will move to. Where should we make it go? It should slide to where it already is, plus some small random offset, say up to 50 units away. If this is where the enemy is, then we could pick anywhere in this square area. The right edge of this square is the enemy's X position plus 50, and the left edge is their X position minus 50. The top and bottom are the enemy's Y position plus and minus 50. If we pick a random number between negative 50 and positive 50, and add it to the enemy's X position, and pick another random number in the same range, and add it to their Y position, then we'll get our destination. This means we want to start with the enemy's X and Y position, and then add something to that. Click the medium blue Motion category, and find the X position and Y position reporter blocks. Drag a copy of each of them into the code area. We want to add something to each of these, so click the green Operators category and find the plus block. Drag 2 copies of it into the code area. Put the X position block into the left value field of one of them, and then put the Y position block into the left value field of the other one. Now we need our random number. Find the Pick Random block and drag 2 copies into the code area. We want 2 numbers between negative 50 and 50, so type the number negative 50 in the left value field of each of the Pick Random blocks, and type the number 50 in the right value fields. Next, drag and drop one of the Pick Random blocks into the right value field of one of the plus blocks, and drop the other Pick Random block into the right value field of the other one. Now, put the plus block with the X position reporter block inside it into the set block for the MoveEndX variable, and put the other plus block in the other set block. Now comes the part where we actually make the sprite move. Click the medium blue Motion category. Find the second glide block and add it to the body of the Move function. We want the enemy to move to the position defined by our new variables, so click the orange Variables category and find the reporter blocks for the MoveEndX and MoveEndY variables. Put the X block in the middle value field in the glide block, and put the Y block in the right value field. Now the function is complete. Click the green flag to try it out. The enemies all move around at random. This isn't bad already, but let's refine things a little bit more. We haven't given any thought yet to the duration of the enemy's movement, and it would look pretty cool if it was random every time. Click the green Operators category. Find the Pick Random block and put it in the first value field of the Glide block. How long should the movement take? Let's start with a random duration between half a second and 2 seconds. In the Pick Random block's left value field, type the number 0.5. In the right value field, type the number 2.0. Next, let's make the enemy pick a random amount of time to wait between each movement. Right-click the Pick Random block you just added to the Glide block and choose to duplicate it. Put the new copy in the Wait block's value field. Feel free to change the range of values, but these numbers should work just fine. Click the green flag and try it out. Now things look really chaotic. This swarm of crabs looks like something you'd find in a tide pool. If you watch them long enough, you may notice that the enemies can move all the way down to the bottom of the screen into the hero's area. This increases the difficulty of the game quite a bit. To limit their freedom, we can make the enemies use the hero's top boundary as well. Let's set that up. What happens here is that sometimes when the enemy picks its random spot to move to, it picks something too far down on the screen. All we have to do is check the move and y variable right after we pick it at random. If it's below the boundary, then we set it to be equal to the boundary instead. If, then, we need an if-then block. Click the gold Control category. Find the if-then block and drag it into the code area. Remove the Glide block from the body of the Move function and attach it to the bottom of the if-then block, and then add the if-then block to the body of the Move function. For its condition, we want to compare the move and y variable to the hero top boundary variable. Click the green Operators category. Find the less than block and put it in the condition slot of the if-then block. Right-click the Move and Y Reporter block inside the Glide block and choose to duplicate it. Put the new copy in the left value field of the less than block. Then click the orange Variables category. Find the Hero Top Boundary Reporter block and put it in the right value field. Now we need to set the variable to give it its corrected value. Attach a Set block inside the mouth of the if-then block and select Move and Y from its list. Right-click the Hero Top Boundary Reporter block in the less than block and choose to duplicate it. Put the new copy in the value field of the Set block. Now click the green flag to try it out. No matter how long you watch the enemies, they will never be able to reach the bottom of the game window. Let's recap what we've learned in this video. First, we revisited the topic of how to simulate movement. With velocity, we can move something in a chosen direction by repeatedly nudging it a short distance. Then we learned about linear interpolation, or lerping, which lets us pick a destination and a duration for movement. When we lerp an object from one point to another, it smoothly passes through all of the points in between as well. We learned that we can use linear interpolation in Scratch with the Glide block. Finally, we used the Glide block to give the enemies in Scratch Invaders the ability to move. In the next video, we'll learn about how text is stored and used in Scratch.